Welcome to the third video series of Arduino Basics, and in this video we will be looking over what is microcontroller and how does it differ from a microprocessor, and lastly we will look over the architectural basics of Atmega 328P. So without wasting any more time, let's get started. Microcontroller is a mini computer embedded on a small chip. It has its own RAM and flash memory that it uses to store information, and also a general purpose input-output or GPIO pins to control the peripheral devices. In a simple sentence, a microcontroller is basically the brains of the whole operation. Think of microcontroller as more like a function. A function takes in an input, processes it, and spits out an output. So the controller is used for simple and repetitive tasks. We use microcontroller in our daily lives, for example, calculators, washing machine, television, cameras, smartphones, etc. Microcontroller is not to be confused with a microprocessor. We're all pretty much used to the processor chips like Intel dual core, quad core, octa core chips that is embedded into our PCs and laptops. So the processor is used for multiple and complex operations, whereas the controller is used for simple and single tasks. And because of the simple operations, its clock speed is on a lower scale than a processor. For example, the Atmega 328 controller that is on the Arduino board has a built-in clock speed of 8 megahertz or 16 megahertz when a 16 megahertz oscillator is applied on it. Whereas the microprocessor has a higher clock speed ranging in gigahertz, that is 1, 2.6 or 3.2 gigahertz. Even though it has higher functionalities, the processor does not have a full capability of a computer. It's a central processing unit that only processes the information, whereas the controller has a full capability of a computer. It has RAM, flash memory, and general purpose input output pins that is used to control the devices. Now we will look at the datasheet of Atmega 328P. So in browser we search Atmega 328P datasheet, then click on the first link. Now we will be directed to the PDF page. So here the first information that we see is it's an 8-bit AVR microcontroller. So all the internal calculation and mathematical calculation it does, it's an 8-bit format. And then it's a 32 kilobyte in system programmable flash. So the internal storage that it has is 32 kilobytes. Then it's advanced RISC architecture, and its counterpart is CISC architecture, which is complex instruction set computing. The microcontroller uses RISC architecture. What it really means is that in a basic sense, one instruction is executed using one clock cycle. Whereas the CISC architecture is complex instruction set, and that one instruction is executed with multiple clock cycle. So that is why the microcontroller and the smartphone that we have, most of them use RISC architecture, and the internal architecture and also the physical hardware component that is used to manufacture these kind of devices, it's much more simpler than a CISC architecture. The Intel processors that we have in PCs and laptops, they use CISC architecture. So another important information is 32 by 8 general purpose registers. So the AVR microcontroller has 32 different registers, and each of those registers is 8-bit long. So these registers are used to fetch information from the memory, and then processes the information, and then write the information onto the RAM. Another important information is up to 16 MIPS. MIPS stands for million instruction per second. So 16 million instruction per second with 16 megahertz basically tells you that each instruction is executed with one clock cycle. Each instruction normally varies, but most of them are executed with one clock cycle. Then 32 kilobyte of storage, as we saw above, and then 2 kilobyte of internal SRAM. Then lastly, 8-channel 10-bit ADC. So the analog information from the environment is converted into into digital component in terms of 10 bits. So the lowest number that you can represent in 10-bit is 0, and the highest number that you can represent is 1023. Then the physical measurements of the AVR, and then all the other internal registers that it has. This is the block diagram, which tells you how each of the components are related to each other, and how each of them are interacting with each other. And this is the AVR architecture of the controller. Over here, it tells you the data memory mapping. It has 32 different registers. It starts from the very top, 0x00, all the way to 0x1f. 0x tells you that the number after that is represented in hexadecimal format. So 00 up to 1f are 32 different registers. And then 64 IO registers from 20 to 5f. Then 160 external registers from 60 to FF. And then internal static RAM that it allocates, it goes from 100 address space all the way to 8FF. So datasheet is used by all electronics hobbyists. So if you have any kind of IC devices, whether it's a sensor, whether it's a microcontroller or other kind of controllers, in order to get more information about the devices, you look at the datasheet. It has every single features and functionality that you need to know. This concludes the end of our video, and if you have learned something new, then please don't forget to like, share, and subscribe. Remember, future is robotics, and until then, I will see you next time.